Hello, I'm Miles Tails Prower. We are ready for the second part. In this part, we'll learn Young's modulus, elastic modulus, bulk modulus, and shear modulus. Now we'll talk about Young's modulus. Young's modulus is a mechanical property that measures the stiffness of a solid material. It defines the relationship between stress and strain in a material in the linear elasticity regime of a uniaxial deformation. We note that the symbol of Young's modulus is Y. The unit is measure in Pascal, equal to kilogram per meter per second squared. Just like we talked about pressure, equal to force per unit area. That's the same thing. I talked with Amy Rose recently. Now, when we derive this formula, we have to write sigma times epsilon by epsilon, equal to pressure, force per unit area, divided by epsilon given by delta L by L naught, which is equal to F times L naught divided by A times delta L, where delta L is the change in length of any material of rod, A is the area equal to inverse of its original length L naught. Next, the elastic modulus, which is similar to Young's modulus. Elastic modulus is so large that it is normally expressed as megapascals or gigapascals. Next, we'll talk about bulk modulus. The relative change in the volume of a body produced by a unit compressive or tensile stress acting uniformly over its surface. Any shape like cube, cylinder, sphere, or cone can be compressed. We can denote bulk modulus as either B or K. We can write the formula K equals minus V times dP by dV, where dP by dV represents the derivative of pressure with respect to its volume. When you consider mass, we write K equals ρ times dP by d ρ, the derivative of pressure with respect to density. The inverse of the bulk modulus gives a substance's compressibility. And finally, the shear modulus is defined as the ratio of shear stress to the shear strain, depending on its angle theta. We can denote it as G. We can write G equals F by A divided by delta X over L, which is tan theta. Then also equal to FL over A delta X, where delta X is the transverse displacement. So, we now have quickly covered the formulas. In the final part, we'd like you to solve numerical questions. Like, comment, and subscribe now.